So we are dealing with problem number 1.34 in the Irodov solving series, and this problem is stating a balloon starts rising from the surface of the earth. The ascension rate is constant and equal to V0. Due to the wind, the balloon gathers the horizontal velocity component Vx equals alpha y, where alpha is a constant and y is the height of ascent. Find how the following quantities depend on the height of the ascent, the horizontal drift of the balloon, and the total acceleration of the balloon. So let us start solving this problem first by understanding a diagrammatic situation. So we can consider this situation diagrammatically like this. So over here at t equal to 0, when y is equal to 0, that is at the starting of motion, the balloon is ascending with a velocity v0. Now as the value of y is constantly changing with each accession, a horizontal component of velocity which is equal to alpha y is also coming into act. So at this value of y which we have drawn over here, a horizontal component of velocity alpha y will also be present along with the vertical component of velocity which is equal to v0. So over here if we start writing the equations, so we can say that the velocity vy is equal to dy by dt, which is equal to v0 and is a constant, and value vx, which can be written as dx by dt, is equal to alpha y. So we have these two expressions. Now if we write the value of dy by dx, so dy by dx can be written as dy by dt, dt by dx using chain rule, and hence over here we can write it as that dy by dt can be written as vy and dx by dt can be written as vx, and from here we get the form v0 upon alpha y. So therefore from equation number 1 which we have this one, and equation number 2 which we have as this one, so for using these two expressions we have obtained this third equation, and over here we can write that dy by dx is equal to v0 by alpha y. So if we take the term of y towards y and x on the other side, then we get the expression as alpha y dy is equal to v0 into dx. Now if we integrate this term, so on integrating this term, so we say that for a certain value of x we will have a certain value of y. Now at x equal to 0, y is equal to 0. So for a certain value of x we will have a certain value of y, and from here we can write alpha y square by 2 is equal to v0 x, or from here we can say that horizontal drift x is equal to alpha y square by 2 v0. So this is the horizontal drift, the first part of the problem which we are looking for. So this is how we solve the first part of the problem. Now in the second part of the problem is asking us total acceleration. So if we solve for total acceleration, so we are using the two component over here also. So we are solving for total acceleration, and over here we can say that ay which is equal to dy dvy by dt. So over here since the y component of velocity is constant, so therefore the acceleration in the y direction is 0, and if we solve for the horizontal acceleration, that is dvx by dt, so we can write this as alpha dy by dt, and we write it as alpha v0. So therefore the total magnitude of acceleration will be solely in the x direction, and the magnitude of acceleration if we write, so the magnitude of acceleration is alpha v0. So this is the second part of the problem. So over here this is the first part of the problem and this one is the second part of the problem. where we are dealing with the ascent of balloon when a horizontal component of velocity also starts uh, playing along, which is equal to alpha y. So this was problem number 1.34 of the Irodov solving series.